Hello friends, welcome to this session. Today we are discussing the relativity. The theory of relativity that deals with the relative motion of bodies is called theory of relativity. The theory of relativity shows that the classical mechanics is not applicable to bodies moving with velocity nearer to the velocity of light. According to classical theory, space and times are absolute. Absolute is nothing but perfect and complete. The flow of time is assumed to be uniform in all situations. That the movement of time and time intervals are identical in all frame of references. And that similarly, lengths are also identical in all frames. But these concepts are not valid at high velocities. The theory of relativity provides many new concepts such as the length of moving body contracts in the direction of motion, clocks in motion slow down, at a high speed space and times are no more separate but merge into space and time continuation. The mass of moving body is greater than its mass when at rest. If the position of the body changes with time, we ordinarily say that the body is in the static of motion. And if its position does not change with time, it is said to be at rest. There may be two kinds of rest and motion. One is absolute and then another is relative. A body is said to be in absolute motion when its motion is observed with respect to a point which is stationary in a space. But in the universe, we do not know any point which remains always stationary. Therefore, absolute motion can only be imagined and practically it has no importance. In the universe, every body is in static of motion. Earth, Sun and other stars are moving all the time and thus any body does not remain stationary. Hence, the absolute rest is also imaginary. In fact, motion and rest both are relative. A body will be said to be in the state of motion or rest with respect to another accordingly if its position changes or does not changes relative to other. For example, a tree on the ground or any building on the ground is at rest relative to the earth. But the same tree and buildings are in the state of motion relative to the sun. Because firstly, the earth with this tree is constantly rotating round its axis, and secondly, it is in motion, moving in its orbit, moving in its orbit around the sun. Suppose A passenger sitting inside the train, that is relative to the passengers that are at rest, but the outside the trees, buildings, etc. are in the state of motion because the train is moving with constant speed. So the passengers are in stationary mode while the trees and buildings, they are moving opposite direction. It seems to be moving in opposite direction, although they are rest with respect to earth. So we feel that, or we assume that, the trees and buildings are in motion with opposite direction of the speed of train. From this concept, it is clear that in order to describe the motion of body, we should know essentially that with respect to what this motion has been measured. If we may imagine a coordinate system, because the coordinate system is the simplest form to describe the position of the point. A coordinate system for which the coordinates of a point are its distance from a set perpendicular lines that intersect at the origin of the system. So such coordinate system attached to a rigid body, and we describe the position of any particle in a space relative to it. Then such a coordinate system is called a frame of reference. In regular life, what is the frame and what is the reference? The frame of reference is nothing but a set of basic assumptions or situations that determines and sanctions the behavior. For example, if you are taking a black color person, and that person is also wearing a black shirt, so how we can determine it? If we are taking the photos, your passport photo, and the background is same color of your skin, then how we can determine it, the personality? So for that purpose, the frame of reference is essential to measure the coordinate system. That's why a change in position, that is equal to motion. Here the image is not motion. The frame that describing the points and reach to the your eyesight, that reference is describing the behavior of that image. In simple language, for the location of the objects, the position vectors are drawn from the origin of the coordinate system. The origin may be coincide with the position of the observer or not, but an observer uses a frame of reference which is stationary relative to him. So the simplest frame of reference is a Cartesian coordinate system. In this system, the position of particle at any point of this path is given three coordinates, that are the x, y, z. Now at any instant, the position vector r drawn from the origin to the particle. Here, a frame of reference is a coordinate system that relative to which the position and motion of body may be described, in which the position of the particle or body is specified by three coordinates x, y, z along the three perpendicular axes. The choice of frame of reference depends upon one's convenience. It means the choice is different with the different observers. This choice is arbitrary. The velocity of a body in motion is measured with respect to the frame of reference. The frame of reference is selected in such a way that the law of nature may become fundamentally simpler in that frame. So there are two types of frame of reference. Let us discuss. As we know, the Cartesian coordinates is the very simplest frame of reference. In this system, the position of the particle at any point of its path is given by three coordinates x, y, z. Now at any instant, the position vector r drawn from the origin to the particle and is given by r is equal to xi plus yj plus zk. To describe the fully motion of particle, we must know its position at different instant of time. That is, the position of the coordinates r should be expressed as a function of time. Then the velocity and acceleration of the particle will be given, that is v is equal to change in position vector with respect to time. So the acceleration is dv by dt or d2r by dt square. In general, for the location of an event in a frame of reference. Now, what is the event? If a physical phenomena occurs in a space, its position is known as the point. The time of occurrence at that point taken together are called an event. Suppose we are observing the plane in the sky and it is far away from the observer. So we see that plane is referred as a point and we cannot determine the motion of the plane. Like you are observing the moon. The moon is in motion. That motion is relative to the earth and we are observing that if you are walking, we feel that the moon is also moving with the direction of observer. But if you are at rest and you are observing moon, we cannot determine the motion of the moon. But as soon as some clouds are in front of the moon, we feel that actually the clouds are in motion and the frame of reference, that moon, we seems that the moon is moving or the moon is in motion. We feel that. In a frame of reference, we require its position and the time of occurrence, and therefore for this purpose four coordinates x, y, z and t are required. T for time. The reference system employed for this purpose is called space-time frame of reference. To describe the motion of a body and it depending on the frame of reference with respect to which the description is given. But in general, that the frame of reference is employed in which the motions are easy to describe. Now we are considering this a few examples. With this help of examples, the truth of all these statements can be explained. Suppose draw a line with a 10 centimeter and draw again a parallel line with a 20 centimeter. Okay, now without touching this line, make the first line shorter than the first line longer than the second line, or then first line makes shorter than the second line. For this example, draw us another line to make with a 25 centimeter, so the line A becomes shorter and line B also becomes shorter. So we can say that this first line or second line is relative to with each other, and first and second is also relative to the third one. Another example, the motion of an aeroplane with respect to another aeroplane may be very different from its motion with respect to the ground. In view of convenience, the motion of the aeroplane relative to the ground can be represented easily. So this is the example that describing the motion of aeroplane relative to the ground. In the river, there is a boat. In the center of the river, there is a boat. And the direction of boat is opposite to the flow of a river. And the two observers observing from the bank of river which is opposite to each other. Suppose A is in the our side and B is in the other side, and we observe that the person A is said that the boat is in moving left to A, while the person B is moving said that the boat is right to left hand. Here the boat of motion is relative to two different observers. As per their convenience, say that one is saying the boat is moving in left to right, while other is saying that the boat is moving left to right. This is the position relation with the motion. Now the best example, generally we are observing when we are sitting in the train and the train is moving with constant velocity. Now if we throw the ball upwards, the observer will see that the stone is coming back along the same vertical path. Okay, means the train passenger observing, or first of all he throwing the ball in upward direction, the ball is moving downward direction or coming back along the same vertical path. At the same instant, observing by another observer standing stationary on the ground, and he observing that person which is in the train, and that person, that event is happening, that person is throwing the ball upward direction. He sees the ball moving with constant horizontal velocity, and thus that ball move on a parabolic path relative to this observer. Means that observer on who is on the ground and who is in the stationary mode, he observed that parabolic path. Another example, the motion of the planets will very complicated relative to the frame of situated on the earth. But the planetary motions are much simpler to describe when we assume that the sun is the center of the solar system and the frame is situated on the sun, that is the heliocentric frame. Thus, to describe the motion in a simpler way, we always try to select a proper origin of frame of reference. However, sometimes we cannot reach the physically there. So this is the example. The ball is in motion vertically and the ball is moving parabolic path. Suppose we stand on the earth and look at the motion of point on the edge of the slowly moving wheel of car. At the edge of, we are marking the point on the edge of the wheel and we are observing that edge of a slowly moving wheel of car. The point will be seen to move through a complicated curve known as cycloid. Thus, a position of vector from us as origin to a point on the wheel performs an extremely complicated motion. But a point on the earth is not always the most convenient origin for the position vectors. If we reach mentally at the center of the wheel and taking its origin, if we study the motion, the point will appear to move on a circular path and thus the motion will be far simpler. So, with the help of this example, we can relate the motion of bodies with the position of the particle. This theory of relativity shows that the motion of bodies. So with the help of this statement, the frames of reference are two types of frames. One is the inertial frame and another is the non-inertial frame. Inertial frames is nothing but unaccelerated frame of reference and non-inertial frames are accelerated frame of reference. So those frames of reference in which Newton's first and second laws hold are called inertial frame, while those are not obeys the laws of motion or Newton's laws are not valid, these frames of reference are called as non-inertial frames. Mathematically, we can describe all these frame of reference in next session. So this is the introduction part of the relativity and the frame of reference. I hope you understand the basic concept of the relativity, the motion of bodies with respect with the time. So thank you for watching this video.